Okay, now I'm going to go over the interim review, the scientific notation and exponent rules part. So like I said, if it helps you, look on the back of your brain dump sheet and just look at this second half here. And also I'll always refer back to your notes, okay? All right, now let's be careful about this first question. It says which equation below is false, which means 3 of them are true, okay? So don't get thrown off by that, okay? So let's take a look, okay? We have A, okay, now if you think about this, there's a couple of ways you can use this to your advantage. 2 to the 5th and 2 to the 12th. Okay, since they have the same bases, you got to add the exponents. So this is true. We want to find the one that's false. Another way to do it, let's see if this calculator will allow me. If I do 2 to the 5th, which is 2xy 5th equals, okay, times 2xy 12 equals, okay, we get this number. Well, then it better equal 2 to the 17th. So let's check it. 2 to the 17th. It's the same number. So that's true. Okay, now this one, remember you distribute the 5 to the 4. It's the power to power rule. So that's 4 times 5 is 20. So 2 to the 20th, this is true. Now if you want to double check, you can take 2 to the 4th, find out what the inside is, then take that answer and take it to the 5th power, and you should get this 1048576. Well, let's see if we get that was 2 to the 20th. 2 to the 20th, yep, same number. Okay, and then here, when you have division, okay, or, yeah, if you have division, if it helps you, you can always write out all the 2s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So all of these are going to cancel out because I've counted 14. 15, 16, 17, 18, 19, 20. Okay, so what's left? There's a 1 left up here because these are all 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, you get the point. And then down here you have 1, 2, 3, 4, 5, 6, 2 to the 6th. That's true. So this has to be false, which, you know, this is the common error that students make. Remember, 2 to the negative 3rd, okay, you can even check here. 2 to the 3 negative is 0.125, okay? Now, let's see if that's the same as negative 2, oops.
Hessler, Eriza, report to the front office, please. Hessler, Eriza, report to the front office.
So 2 to the 3rd is 8, and then negative 8. These are not the same. They're not equal, okay? They are not the same, right? So this is going to be false. This is the only one that's false. So be careful when there's questions like this. Some students don't even pay attention, and they say, oh yeah, that's true, and then they just circle it because they think they're supposed to look for the one that's true. So just beware of the way the questions are asked. Number 2, what is 3 to the negative 4th in standard form? Well, remember, this is upstairs, 3 to the negative 4. Oops. And it's unhappy, so bring it down. So it's going to go downstairs, 3 to the 4th, and now it's a positive exponent, and you have a 1 left up here. So what is that? So you don't see that, but we know what 3 to the 4th is. 3 times 3 times 3 times 3. Well, what is that? Well, I can do the short way by doing 3xy4 should be 81. So this is the correct answer. Now, since calculators are allowed, you can also just check it. Like, press 3xy4 negative, and you should get, oh, that's not right. Or maybe it is. Okay, 3xy4 negative, you get this thing, like 0.0123, oh, 4, 5, 6, 7, and then skips 9. Oh, it's probably supposed to be 8. Okay, but what you see on your calculator will go with. Okay, and then now let's see what 1 over 81 is. 1 divided by 81, that's the same number. So you know that these go together, okay? This is not the same as negative 81. If you want to check this one, 1 over 12 is not the same number. So these have to be equivalent, okay? It's another way to check. And it's okay if you use your calculator for that. All right, now what is this in exponential form? Okay, so these have the same bases, and you're multiplying same basis, so you add the exponents. If you're not sure if you're really supposed to do that, think about 8 to the 4th. That's 8, 8, 8, 8, and just imagine I multiplied in between. Then you multiply by 12 more 8s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you add that up, that's 16 eighths. So it's this one. Again, if you want to check, you can do 8 to the 4th equals times 8 to the 12th equals, okay, so we get 2.8 times 10 to the 14th. Let's see if 8 to the 16th gives us the same thing, which it does, okay? So number 3 is correct. Here's another one of those tricky questions. Which statement is not true? Then you need to put it in your brain that 3 of these are true. So once again, whatever it takes for you to make sure about these rules, like for this one you have the same base, so you add these exponents. This is false. This is supposed to be a 12. So right away this is false, but let's see if the other ones are true. Yep, 3 times 5 is 15, that's true. 12 minus 15, that's 7 to the negative third, that's true, although it's not completely simplified, but that is true, because 12 minus 15 is a negative 3, and the reason why we subtract is because of the division, okay? And then 5 to the negative third, it's not happy where it is, so it goes downstairs. This is true as well. So the only one that's false is A. Number 5. Now, what do we do with this? This is definitely a trap. A lot of students think, hey, let's just multiply 6 and negative 3. It's not negative 18. Okay? Now, some students think that it's this one because they're like, hey, isn't it 6 times 6 times 6? But it's a negative, okay? Because 6 times 6 times 6 is 216. Let's see. Okay? Or you can just do 6 to the 3rd power. But that negative suggests that it's unhappy. So you need to make sure that the 6 to the negative 3rd goes down and there's a 1 upstairs waiting. So this would be the correct answer, B.
Hessler and Risa, if you are in the building, please come to the front office. Your mother's here. Hessler and Risa, please come to the front office. Thank you.
Okay, so I have here, I'm just drawing arrows to show my work was directly on here since, I asked you guys to show work. But if you're showing work directly on here, that's fine, okay? Number 6. All right, so this is a little bit more multi-step, but don't let this throw you off. You guys should be able to do this, okay? When you have power to a power, now you might be like, why is this 3 raised higher? It doesn't really have any special significance, okay? So this 3 is going to distribute to this 2. So 3 times 2 is 6, so this 3, this base stays 3, while this turns into a 6, and you got 3 to the 5th here. Now, since you're dividing, you actually subtract exponents, but if you're not quite confident about that, then you write your 6 3's up here. Just imagine it's multiplying, multiply, multiply, and then you write your 5 3's down here. So remember, this turns into 1, 1, 1, 1, 1, and you're left with 1 3 on top. That means there's a 1 on the bottom. So what is 3 divided by 1? 3 divided by 1 is just 3. So this is a trap. Don't think the 3 is on the bottom. The 3 was on top. So make sure you pick the number that truly represents that, because you can think of any whole number as over 1. Okay? So it is not the same as 1 over 3. Do not pick that one. All right. Let's go to number 7. Number 7. Okay. So now we're in scientific notation. I'm going to give you a little, we haven't done a problem like this, but I'm going to ask you to just use your calculator for this. I don't think they're going to have a question like this on the interim, but in case they do, since we're working with scientific notation, we're going to put our calculator, and I know you guys don't have this calculator at home, so just pay attention to how I'm doing it. So first, you guys know, how do we put it in scientific notation? Well, on your little sheet here, we said mode 8-3. Okay. Mode 8-3. Okay, so now we're going to put, what I'm going to ask you to do here is just put this in. Okay, 0.61, 0.61, EXP, and then 12 for this 12. Now watch what happens when I press equals. It's going to give me the proper scientific notation. There it is. How that does that, that's a whole other story, but for now, I want you guys to know that that's correct. So 6.10. Okay, all of these start with 6.1 except this one, so that's out. Times 10 to the 11th. So this is the one with the correct one, and that's your answer, A. So not much work here, so the work that I did was circling correct answers and canceling out numbers or wrong choices. Okay, number 8. Which expression shows 23.7 times 10 to the 5th in proper scientific notation? Again, we're going to use our calculators for this, so mode 8-3. And we're going to put in 23.7, okay, EXP 5. Now watch what happens when I press equal. It's going to put it in proper scientific notation. The decimal's in the right place. 2.37 times 10 to the 6th. The one that does that is A. All right, number 9. Which expression shows 20,010,000 in scientific notation? Okay, so there's a couple of ways to do this. If you do this by hand, okay, this decimal is going to be, the decimal should be here. Okay, so that becomes 2 point, since the 1 comes over here, I need to include the 001, 001. Okay, so I'm going to multiply, in order to expand it to make it that big, I need to go to the right. Okay, so how far to the right? 1, 2, 3, 4, 5, 6, 7. So I'm going to go 7 to the right from the decimal. And which one does that? Not this one, it is this one. Now, for those of you that are tech savvy and you're okay with the calculator, this is kind of something cool that your calculator does. We didn't get to this in class because I just learned about this, but if you guys are watching the video, this might be something that's helpful to you. So make sure you're in scientific mode. So there it is again, mode A3. Now watch what happens. If you just press 2001000, okay, so watch. Okay, 20010000, and you just press equals because we're in scientific. It's going to change it for you. So it is. Wait a minute. Oh, but the reason the 1 is missing is because that's 4 digits. So again, if you don't understand what I'm doing, that's okay. But in this case, I would have to do mode 8-4. So I include all 4 digits here. So you put 2000, whoops, 20010000, and that's what would your answer be. Okay. Again, if that's just something I'm showing to those of you that want to know a little trick that I didn't get to teach in class, but that's just an added kind of little trick that could help you, but if it doesn't, then just go back to, okay, the decimal should be here. I'm going to include the 001, and then it should go to the right to expand out. So 1, 2, 3, 4, 5, 6, 7. If it helps you, number them. Okay, and then that's your answer. And make sure you pick the positive one. This is a trap. Okay, be careful about that. Number 10. What is 7320000? That's another big number. Where's the decimal supposed to be? Should be here. So if I write that 7.32, to expand it out to make this big, I have to go to the right. So it's going to be times 10 to some positive exponent. So I go right how many? 1, 2, 3, 4, 5, 6, 7. Again, if it helps you, number it out. So that's positive 7. So it's, make sure it's 7.32, so it's not that one. Times 10 to the 7, positive, so it's C. And if you want to use your calculator, you can. Okay, so mode 8, since I have 3 digits, mode 8-3, and then if I just put in the standard 7320000, it's going to change it right for you. But again, don't figure it out. I mean, if you don't understand the calculator, since you can't practice this at home, just do it the old-fashioned way, put the decimal where it needs to be, and then decide how far you have to go to expand it, and we had to go to the right 7, so therefore it's a positive 7. Okay, number 11. According to the Bohr model, again, you don't have to worry about knowing what that even means. We just trying to figure out the math. The radius of a hydrogen atom is approximately that meters. What is this number expressed in standard form? Oh, so we just got to change it to standard form. Now, if you see this, I'm going to have to move left 11 from the original decimal point. So I'm going to have to do left 1, and then I have to go 10 more zeros, okay? So you can go ahead and draw that out, but I can tell that this is 1, and then I'm going to have to add 10 zeros to make it move 11. So I'm going to look for 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 5, 2, 9, because once again I moved 1, started here, 1, 2, 3, 4, 5, 6, 7, 8, 9, uh-oh, maybe I put too many. Oh, no, it's 11 because I need to go 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So look, count, oh, be very careful here. One of these is definitely a trap. Okay, so count 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. And then 5 to 9. This should be it. Why would this be a trap? Because some students think, hey, I should have 11 zeros, but that's not the case because you had to go over the 5 before you can start adding the zeros. So here, this looks like it has one extra zero. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But that's not reflecting this number. And then these are too big. These are positive exponents because they expanded the other direction, so it can't be those. And that's a trap. And number 12, the radius of the Earth is approximately 6,370 kilometers. What is the distance in scientific notation? Okay, well, the decimal needs to be here. So you would write it as 6.37 times 10 to the, now I have to go this way to expand it back out, so 1, 2, 3, positive 3. So it's not negative, that would put the decimal in the opposite direction. This is not even in the right place, and the exponent is not correct, so out of these two, it would have to be C.